Thank you, and it'll be a pleasure to talk to an august audience of professionals in a very noble industry like the healthcare. It's always been a dream, for engineers to see what doctors do. I've been a lifelong engineer, and so it's always been puzzling what the other side looks like. But thanks to AI, we are seeing a lot of views of the other side, which is healthcare, and healthcare is definitely one of the big adopter of AI. So before going there, I'd like to just mention that I am an avid buff when it comes to AI. My BTech way back in 1988 was on AI, machine translation. MTech was in AI, PhD was in AI. So I've been a thorough believer in AI for the last 40 years and 30 years plus at least. So I'm happy to see this kind of juncture where I'm able to talk about not just the theory but also the practice of AI penetrating common man's life. And I think I'm really seeing my life's mission fulfilled because of this, because my faith in the area, having stuck on the same area for 30 plus years, also puts a lot of credibility to the fact that my hunch was right, that someday AI will be there. So what I'm going to talk today is about a couple of possibilities. Some are real, some are happening. But I will also give two different contexts to my talk. One is the Indian context. What is the imperatives from an Indian context of adopting AI in healthcare? Then I will also talk about, while there is a lot of gung ho, a lot of euphoria about adoption of AI in the different fields, there are some showstoppers which also need to be handled in a graceful manner for overall adoption of AI. So my talk will be three parts. Firstly, overview of AI. Then, what are the possibilities of AI on some on the clinical side, some on the non-clinical side, and then I'll try to give a little bit on what are the imperatives from the Indian context, and also highlight some Indian success stories, what is happening out there. Then I will also come back to saying that okay, all the things are good, but it's not all rosy. It is a bed of thorns as we speak. And my company affiliation here, which I have written, testaing.com, is my latest venture where I'm trying to develop a product handling some of those showstoppers in AI deployments. So that is the selfish interest of mine, in the sense that while I know people like to hear AI successes, but what I want to make sure is every AI success goes without failure. That is my goal. At the same time, I'm also a very avid fan of spreading knowledge about AI. So I'm putting in my chat my own channel, which I run for my company, Tara AI. So we are very much deep into making sure that everybody out there becomes avid AI buffs like us. So we keep regularly publishing videos around different aspects of AI to educate people. So I request all of you to go through the channel, subscribe, and spread the word. And my goal is to spread awareness, just like this talk. It's not should it be restricted to this talk. If anybody has access to a YouTube, you should be able to go back, study different aspects. So this includes a comprehensive set of 100 odd videos, which we are planning to increase it to 500 videos in the due course of time, to spread awareness of AI in different classes of people, from students to professionals. So that's the 2-minute blurb which I wanted to tell. So I'll put two elements of my passion for AI. One is this education channel, which you can all subscribe to. Second is this panel, this specific new product which we're launching in testaing.com for handling deficiencies in the deployments of AI. So our goal is to make a really smooth and steady scalable deployments of AI in different verticals. So can anybody tell me here, what is this famous example? Any of you can put in the chat. This is a famous AI program out in the middle. Any thoughts? Any of you? The middle program is an AI program in this screen. Any thoughts? Anyone? Any guesses? Okay. So have you heard of Watson? IBM Watson is the name of the machine. It is basically an AI program which beat world Jeopardy champion. And Jeopardy is an area where lots and lots of general knowledge is required for different aspects of universe, earth, physical science, general science, all kind of different aspects. You can be asked questions on any dimension, anywhere, using anything, any kind of knowledge base. So this went on to beat the world Jeopardy champion. And imagine the complexity of being able to replicate the general knowledge and also being able to respond faster than the human champion. And that is exactly what has happened when we talked about creating a scenario for allowing a computer to take on human champions in domains which are conventionally very human centric. So that when IBM saw the success, you know what it did? The next thing what it did is it started creating Watsons for different domains of healthcare. So it's still on the attempts by IBM Watson to create Watson machines for every aspect of different diseases across the globe is a big endeavor they have taken up. So there is Watson for lung cancer, then there is Watson for specific kind of disease. So what they want to do is they want to create a really robust diagnosis engine for every kind of disease out there. That is what is basically the goal of the Watson program today in the healthcare as exhibited by IBM in its market strategy for taking Watson. Healthcare is the first vertical where they're taking it for different diseases. So what is exactly AI? AI, if you see, it is about intelligence as exhibited by humans by any software or a hardware like robot inculcated with enough intelligent software. That's basically what AI is all about. When I say AI, it's about emulation of human intelligence. So what does human intelligence mean? It should be about perceiving different inputs, could be sight, could be voice, hearing, reading, listening. But unfortunately, two aspects have still not been emulated in AI, namely the aspect of smell and the aspect of touch. Other than that, all the other capabilities of humans have been emulated in modern AI. And that is the reason why we're seeing AI getting close to business, because we're seeing you've got to be cautious that in the realm of AI specialists, we still feel we are in a very, very preliminary stage of AI called ANI or artificial narrow intelligence, which is meant for scenarios of AI where we are having very good narrow tasks, like winning the Jeopardy program better than the human champion, winning the chess program against Kasparov, winning the Go game against the current champion Lee Sedol, or being able to perform a specific version of driverless car better than humans in reducing accidents in a narrow domain, like say California roads. But the problem comes when a trained AI agent on say a game like let us say Go, you go and ask it to go play chess. The same program will fail miserably because the training of the program has happened on a very narrow domain like the Go game. Same thing, let us say we have a cancer detection program for, let us say, lung cancer. You go and ask it to go and diagnose pancreatic cancer, it cannot. The reason is today's notion of AI, which are all successful examples we're seeing, right, from cancer diagnosis to game winning programs to driverless cars to risk analysis programs, all of them are based on training the bot, training the specific AI program on a very narrow domain and expect it to become super smart in that particular domain, maybe better than the best human in that domain. But the moment you change the domain, it will fail. And that is where humans are considered superior, because for us, changing a weather condition will allow us to homostasize and change our behavior depending upon the weather. Or if you learn left-hand driving in India, sorry, right-hand driving in India and go to US, it doesn't take you more than 1 or 2 days to acclimatize to go to US and start driving in one day. These are the generic dynamic reconfigurability concepts of human beings, which are still very far away for AI programs to pick up and be able to deliver. Till then, we will be in the realm of a lot of successes around ANI, or also known as weak AI. But AGI is where general intelligence or strong AI, where it's expected to mimic humans to the core, whereby even on changing the scenario, where you need to look at the application, changing the game, changing the scenario will not require you to do massive reconfiguration or rechange. That is the day when you say you can have human level AI or AGI or general AI or strong AI. That is at least 40, 50 years away, because a lot of people don't even understand what dealing with uncertainty is in context which humans are very good at. Machines are not so good at. So human level AI or AGI is still far away. But when you have a human level AI, which is AGI, people say you can probably have super AI, ASI, which is smarter than every human being in every task. Okay, that's possible. But I think the rumor mongers have to worry about first getting AGI, then ASI. So a lot of negative thought and press which goes into AI deployments about creating these monsters is quite often misplaced, and we are still in the realm of a very, very elementary journey of the full potential realization of AI in the ANI to AGI to ASI journey. I hope that's one big thing I always try to clear the air, because people tend to overemphasize the potential technology of AI even at the current level. I'd say that it can solve world hunger. Whereas the thing is, we're still only talking about a very narrow concept of AI as currently practiced by a lot of human practitioners. But why is AI now so important? When I said I started BTech in '88 and AI, the reason is there has been three primary goals: availability of large data, open data, internet, sensors, all social media. They all generate tons of data. Even enterprises have lots of data that gets generated. Cheap compute, that is another big thing. Compute has become very cheap for anybody to access any complex algorithms to be run on demand. And then big compute available in cheap manner. Big compute means large cluster of GPU, NVIDIA GPUs are available at a throwaway price on cloud. So given this three coming together, we are actually seeing internet scale deployment of AI. And in fact, it has been proven that in the history of technologies, over the past 200 years, if you see the amount of years taken by any technology to reach 100% mankind, if you say electricity, it took 150 years. Banking ATMs, probably it took more than 25, 30 years. But AI is probably going to take less than 10 years to reach humanity because of the large scale applications we're using daily. When you shop on Amazon, when you search on Google, when you ask Google Maps for driving direction, when you ask Google to translate, all of them are already AI first applications where AI is coming and touching your daily life. So that is the trigger why AI is big today. But let's come to healthcare. When we talk about healthcare, we view this as one of the most prominent vertical, which is going to probably look at using AI in a big way. So as I said, AI is all about mimicking human intelligence by making use of insights generated from data. So when I talk about AI, one thing that comes into mind is what is the engine of generating this intelligence? What is that engine inside which is allowing a game winner to be capable against humans? Or what is it that is able to let a AI program diagnose what is there inside X-rays of cancer? Or what is there inside this program, which is allowing the cameras to detect obstacles automatically? And that particular technology is called machine learning, or ML. And ML is basically short form for what is called as machine learning. And machine learning is a very simple idea. The idea of machine learning is, in very layman terms, it is called as pattern recognition. I'm sure many of you have heard of that concept, right? Pattern recognition. So what happens is, in ML, you have tons of data, you give a lot of instances of data. And then when you apply ML, it extracts pattern from the data. The data which could be given to ML could be images, could be normal tabular data, could be text, could be audio, could be video, could be long sensor data. But any kind of data, when fed into this ML, it generates a pattern. It tries to understand from the entire input data that's been given. That is the core of ML. ML is about pattern extraction from a lot of raw data. So when you have a lot of raw data and you extract the pattern from there, what is the use? The use is what we call as predictive analytics. Predictive analytics is a branch of analytics which talks about using something or predicting something for the future. So what kind of things you can do for the future? There are two kinds of things you do in the future. One is predicting what kind of value a certain variable can take in the future, or you can say predicting a future image in terms of one of the classes. So I'll give you the example of the classes. Suppose you're given tons of X-rays related to, say, pneumonia patients. Some of them are actually having pneumonia, some of them don't have. But you labeled each one of the X-rays saying this is pneumonia, this has no pneumonia. Like that, you give 1,000 images to the machine learning program. The machine learning program will detect the pattern inside it, create an internal map of the pattern. When a new X-ray is given to it, it will automatically tell whether that particular X-ray has pneumonia or not. So here, output prediction is one of the two classes. Has it pneumonia or no pneumonia? Same way, let's take another example. Let's say I'm looking at sentiments of all the tweets which are being generated by social media warriors for my company. I want to see if they are positive or negative or neutral for my company. So what I do is I collect thousands of tweets related to my company products in the recent past, label them. This is positive, this is negative, this is neutral. Like that, I feed it to my machine learning program. It will understand the pattern inside the tweets and understand which one to put into when a new tweet comes. So when somebody has tweeted a new, oh, it's great, sounds great, it will take it and suddenly says, okay, here is a positive review in favor of your company by having looked at the past data. But it's not that in all cases you have exact idea of how many potential values output can take in terms of classes. There are several times when instead of classes, you have to look at predicting a value. For example, I give my sales data month on month, week after week to my machine learning model. It will internally create a particular model and then use it to predict the sale for my next month. So there you talk about predicting something known as the value of my sale for the next month. So when you talk about ML use cases, you can mostly look at two things. One, either you try to predict a future value. Say I'm talking about a sale. I'll see what is the next possible sale volume. Or I can predict a class. Given an X-ray collection, I will predict whether it has cancer or not. So both ML are today forming the backbone of the AI use cases. So today, AI is mainly driven by the ML, which is machine learning, which is nothing but pattern extraction from raw data, which is useful for some predictive feature. And that is where most of the analytic use cases of AI lie in healthcare domain. So one of the big category of work which we want to look at it from perspective of automation is highly repetitive work can be automated by use of AI enabled software or robot or hardware bots. This could be things like if there are standard workflows related to creation of a new customer record, new patient record. I'll give you a project right back home here. Today, there are components of the workflow inside a hospital. Like, for example, a doctor prescribing a particular case medicines related to a particular observation of a patient, so and so, say paracetamol, BD, then say 150 mg for 7 days. So today there are applications of AI where a doctor just has a headset on. He speaks into that, the prescription. The prescription automatically goes and fills up the hospital ERP corresponding to the specific patient who's been looked at automatically. And this is a classic example of earlier, if you had to do that, imagine if you had to have a doctor fill it up. It would be 4 different screens, each screen having 10 fields and all of them having to be filled up, which sometimes even if it's empty, they will ask you to fill it up. It can be a boring task of filling. And imagine the possibilities. This is just one example I've given where a doctor is filling 120 kind of blanks in a 4-screen ERP. Now with AI-enabled system, he just speaks into the system. The system picks up from the speech, converts internally to the phonemes, to text, then converts it into the appropriate named entities and can be forwarded into the corresponding database to be filled up so that the form can be filled up. So that is a very clear example of a repetitive work which often happens in the context of different hospital workflows. So my request to all of you is look at end-to-end workflows. Could be clinical, could be related to hospital operations, could be related to patients, could be related to even drug discovery, for example, maybe the back end where people discover drugs, workflows. They're called biological workflows. All of them have potential to be really automated or at least optimized for better performance and throughput. So that is one theme which is running around how AI can be used in healthcare. Any workflows with repetitive work, you can try to use AI to make things better, faster turnaround, lesser response time, and more optimal process. Next one is the whole concept of augmenting and empowering doctors by helping them deliver faster and more accurate diagnosis. This is where the typical conventional argument, in fact, just even while introduction, we were told about, are they going to replace doctors or are they not going to be replaced? What we believe is in the context of India, I speak in the context of India, where the density of healthcare professionals is quite small, this should be viewed as a way or a lever to increase the turnaround time for a doctor and thereby increase the throughput in terms of number of patients they can see per day. And I would like to also add that this can actually be combined with the notions of telemedicine and telehealth to deliver to remotest areas, to remotest patients, poorest of poor patients, and to people who are remote in remote towns, villages. So the idea is we should use AI as an augmentation engine for improving the overall efficiency of the healthcare delivery by providing more doctors per patient by using this, rather than saying that I will use AI to replace doctors. It's not about replacement. It is always about augmentation. So to me, AI's most powerful incarnation is what is called as IA, which is intelligent augmentation. Never try to look at it purely from replacement. think of it from augmentation perspectives. So you can think about additional expertise and assistance to professionals, like we're talking about care bots. So there are lots of different example deployments of today, both hardware and software. Why I say hardware? Because there are a category of robots sold by NEC, Japan, which are small toy robots, which are meant to be just emotional companions to people. They will work, they stay along with the patient, understand, listen to them, empathize with them, even sometimes have conversation with them to remove their loneliness, etc. So it's not that you can only do that with a chatbot. You can also do that with a chat assistant, but either you do it with software purely like chat assistant, or you can do a cobot, which is a small robot, which can be empowered with smart intelligence to give dynamically assistance. So there is a lot of work going on in making personal assistants, either at robots plus AI software or purely AI software based chat engines, to help the companionship issue of a lot of lonely people, to be there as companions. That is one aspect. Another aspect is, can we bring context awareness to people with dementia? There, people are talking about combining sensors, on-body sensors, plus the analysis done in the backend AI. We can provide contextual intelligence to dementia patients as and when where they are. So that is what we talk about, the physical manifestation of AI, where AI is working closely with the sensor technology to be able to give a very simple solution to the problem of memory loss. So I can go on and on in this whole area of augmenting the human as a theme. Then robotic automation in routine operation is similar to the first point where you say automate repetitive work. Today, there is a requirement of optimizing workflows. The next one is very important: intelligent operations by dynamic optimization. This is something based on some real case studies we've done, where we actually analyze, suppose somebody has done a day-long test. Another one, suppose, has done maybe partial tests, and there is a prescribed sequence. First go to this pathology, then go to ECG, then go to MRI, then go to CT. Like that, you complete the whole cycle. But if we can, on the other hand, by observing dynamically the cues and the different density of operations at every stage, can we offer dynamically the different paths to different people who are taking tests, so that you are more optimally utilizing the time and schedule of the overall tests? It increases the throughput of your whole system, and people are also happy because they can effectively utilize the capacity, and overall turnaround time for tests also reduces. That's just one example of dynamic optimization, which is possible in dynamically changing your workflows, because that's only possible when you have context sensitive data, and you can use that to dynamically change your sequence, workflows, etc. Last but not the least, medical imaging is a whole new area which is entirely getting powered by AI as we go forward. Of course, here again, the debate comes about, do we talk about it as augmentation or replacement? Typically, what we feel is, in the kind of scenario where India is, augmentation is the way to go, where you improve the overall efficiency and try to get more cases through using AI rather than just think about one specific use case. Okay. So one big area where we have seen is AI-based diagnosis. which is the important area where we are seeing that it's practically an irreversible direction where diagnosis of different diseases, different domains have been now utilizing AI at the core. So what is the reason why we want to look at this? This is basically talking about not replacing, but augmenting. How AI helps? It helps in better clinical decisions. It helps replace human judgment in radiology and related areas. And most importantly, we can reduce diagnostic and therapeutic errors. And lastly, we also see that there is increased patient safety and huge cost savings. And the other important thing, which is the concept of preventive health from patient perspective, where in conjunction with fitness devices and sensors, patient can do a lot of self-service, self-diagnosis. Whereas AI system can help even by looking at a lot of data from patients, extracting useful information from patient population, understanding trends, understanding etc. So what we need to look at is AI-based diagnosis is here to stay. It's going to be more and more penetrating. Only thing what we should be careful about is, while there is a temptation of generalization from looking at some past examples, but there should be care taken that every patient specific characteristics are put into place for the modeling rather than taking generic observations and putting it into the diagnosis. Because ultimately, all of AI is about machine learning, which is about taking data So we will be very cautious about generalizing the AI outcomes. So it cannot be done without oversight. It needs oversight from the doctors who are involved. So it has to be viewed as an aid to doctors to help in the diagnosis process. So caveat should be, we should not be overzealous of getting patterns and generalizing it too much. Okay. So that's the caveat I would like to mention. Though I'm an AI buff, I've always put caution on the side, caution at the front, because there have been several scenarios where false positives and false negatives have proven to be very harmful if we don't take proper care in deploying AI. So even if you look at from industry adoption, there are several applications of AI in FDA. And FDA actually has approved several of them. So if you go to this source, the medical futurist, you'll see hundreds of algorithms have actually been approved by FDA. Some of them could be around sleep disorders, some of them are about diabetes, some of them are cardio, some of them are on oncology. But in general, oncology and COVID dominate in terms of where AI research is more prominent. In COVID, there's a whole branch of AI where they're doing from different dimensions. People are trying to just not do imaging. People are trying to see if cough signals can be used as input for diagnosing cancer. So there's a lot of innovation happening around AI in diagnosing different kinds of diseases, right? From oncology, cancer, to osteoporosis, to sleep disorders, to diabetes, to COVID. And this particular slide is very encouraging because that means it is no longer in the lab. All of them are real out there, getting work done in real, actual diagnosis for patients out in the field. So while I talked about diagnosis, screening of patients, etc., is fine. But in hospital typical operations, there are several possibilities where AI can really streamline make the operation smarter, reduce overall cost. Like I mentioned, important workflows can be optimized. So we can do, for example, a lot of pre-screening tasks or workflows of checkups to be done using automation. Virtual nursing is another big interesting area where aid bots can be there, where you can look at diagnosing the some of the preliminary checks, etc. can be done, or somebody can monitor if somebody has taken medicines, etc. And remote telemedicine, along with increased doctor efficiency by use of AI, is probably a killer option for India, because you can actually make available larger number of doctors to service larger number of patients in remote corners of India. Smarter sequencing is exactly the example I gave you, where depending on dynamically the load at different parts in the hospital system, you can try a dynamic smarter way of workflows to be manipulated, so that both the patients get benefit and the utilization of the equipment and workstations in the hospitals get improved. Preventive self-service, this is something I should not have used the word self-service, but more like self-diagnosis, etc. The idea is a lot of insurance companies and healthcare companies are coming together on organizing multiple drives of awareness among patients to carry out preventive diagnostics. It could be self-diagnosing based on medicines. Yeah, we'll do that. So preventive self-service is something which is very useful. Then intelligent operations is, again, as I said, an example of what I was talking about: smarter sequencing, different ways of workflows to be very smartly configured to allow dynamic sequencing, etc. Right? So having said that, this is good, but back home in India, what I feel is we need to localize the context for AI in India, especially in healthcare. Remote and teleoperations combined with AI will really increase the reach of AI to every common man. Solving local disease problems like TB is very important. Today, you talk to any world funding agency, they do not fund if you don't hear words like AIDS, cancer, or COVID. Really, local diseases have not gotten that much attention. It is in our hands to develop AI-specific solutions for some of the local diseases. Overall, lower the cost of care delivery by looking at the operations which are probably can be done at AI at a pre-screening, and then do that. Bring large-scale administrative efficiency by efficient operations. Increase density, increase access density via automation. Multilingual solutions to enhance last mile reach to local population. Today, machine translation as a technology can be a powerful technology for bringing multilingual bots for service to people who only know regional languages. That's what I meant by local context. And shared EMR, this is a very tricky issue, because what happens is approaches to electronic medical records in global countries have lots of issues. In India, we have a potential to make it a large success, but somehow what has happened is here it's turned out to be very, very siloed. Each group of hospitals tries to create their own EMR. There's a very little work happening at a national level EMR. It's not easy, but I think where there's a will, there's a way. When we can create Aadhaar, why we cannot create shared EMR? So this is what I meant when I say contextualize the work of AI for India-specific healthcare. But it's not something which somebody is not listening. There are already successful startups, etc., working on it. SIGTuple, which we've been funding very well, which analyzes blood, semen, urine, chest X-rays, retinal scan for different diagnosis. Niramai, which is standing for non-invasive risk assessment with machine intelligence, uses thermography and machine learning to detect early signs of breast cancer. And this is very cost effective because it does not talk about any more intrusive methods which are currently used. So it's quite cost effective as compared to the conventional systems which are based on vision. A pap smear, for example, by Iandra systems classifies a cancer sample as normal or cancerous. Similarly, there are other products like Cure.ai has something called QXR, which is trained with million curated X-rays and radiology reports and detects abnormal chest rays, identifies 15 common abnormalities. This is just a sample of the population. There's a lot of funding going on now in AI in healthcare. Lots of startups coming up to solve real problems, local. They're not something global. They're talking about local problems, solving local issues. That's all good news. But okay, it's all great. AI is a great technology. It helps the overall efficiency in operations. It helps in improving diagnosis by automation using machine learning. But what are the issues in more broader successful deployments of AI? Lack of sufficient data. This is something which is very important because even for contextualizing a specific strain of certain kind of cancer, you may have to have sufficient number of samples, because it's not like you can talk about pure any kind of sample. You have to have context specific data which is useful for getting meaningful insights. Data quality, which is very often a big problem because a lot of times the data entry is incomplete. A lot of times the sensors may be fully functioning, not getting full data. Ethics, this is a dimension which is still not risen big in India, but already Europe and America are talking loudly about the ethics of AI. Ethics talks about combinations of privacy concerns, bias concerns, accountability concerns, etc. Today in Europe, there are a lot of debates going on about validity of technologies like face recognition, validity of technologies like diagnosis of medical imaging with proper content, with proper intent, with proper permission from patients. It's easy. But what we're seeing in reality is a lot of privacy and GDPR regulations are coming in the way of making this as smooth as just take any data from anyone, then do it. It's not so easy. You have to be compliant with privacy. And then one more important thing is a lot of times you get a diagnosis of a particular X-ray as malignant or something. But do you really trust the AI program? How much do you trust? That's where explainability and transparency are new areas in AI which are coming up for allowing explaining of the decisions they have taken. So this is a new area where once a decision has been taken of something is cancerous, it will go back and trace and tell you which part of the image is actually making it explain that this is a cancerous image. The sum of it all is there are lots of concerns on ethics, fairness, transparency, explainability, and privacy issues of AI, and data quality and sufficiency of data issues in AI. In a really large scale, scalable deployments of AI in the context of healthcare. But these are slowly getting solved. So for example, we have just been in the field and we're talking about releasing this product we're talking about, which handles security, ethics, privacy, and transparency needs of AI deployments. So all in all, I can say AI is here to stay, changing our lives. It's basically based on extracting patterns and intelligence from data. AI is common in several uses of healthcare, including diagnosis, operations improvement, etc. But a structured approach to solving AI problems is also crucial. So you can reach me at any of these email IDs, and I will take any questions. So my request, as I said, is please subscribe to the channel I have put for mine. And for any queries, please reach out to me. This is my email ID. And I really want to see AI succeed in solving local contextual problems for India. So rather than treating it as a negative way, job killer, more automation, instead, let's use it to our advantage to increase density of access, improving operations,